Welcome to solverfy.
For A, the problem is evaluate the integral x to n times e to negative x, integral from 0 to infinity, for n is equal to 0, 1, 2, and 3. So for A, first we can write this is equal to the limit A goes to infinity, 0 to A, x to n times e to negative x dx. And when n is equal to 0, when n is equal to 0, this definite integral is equal to integral from 0 to a e to negative x dx. This is equal to negative e to negative x from 0 to a, and this is negative e to negative a minus 1. And when a goes to infinity, e to negative a's power goes to 0. So the result is 0 when a goes to infinity. This is 0. No, this is 1, sorry. E to negative a is 0, so this is negative 1, so this goes to 1. And when n is equal to 1, this is integral from 0 to a x times e to negative x dx. Here we use the integration by parts. This is equal to the integral from 0 to a x d negative e to negative x. So this is equal to x negative x times e to negative x from 0 to a minus integral from 0 to a negative e to negative x dx. This is equal to negative a times e to negative a plus root of the integral from 0 to a e to negative x dx. So when a goes to 0, so when a goes to infinity, this part goes to 1. This is the case n is equal to 0, so this is equal to 1. And when a goes to infinity, a times e to negative a goes to 0. Here we can use the L'Hopital's rule. This is equal to the limit a goes to infinity, a times over e to negative a is equal to the limit 1 over negative e to negative a goes to infinity. This is equal to 0. So the result is equal to 1. When n is equal to 2, this is a limit a goes to infinity, integral from 0 to a x squared e to negative x dx. Here we also use the method of integration by parts. So this is equal to, this definite integral is equal to the integral from 0 to a x squared d negative e to negative x. And as method of integration by parts, so this is equal to x squared negative e to negative x minus here, so this is plus integral from 0 to a. This is from 0 to a plus x e to negative x times 2x dx. This is equal to negative a squared e to negative x negative a plus 2 times integral from 0 to a x times e to negative x dx. And when a goes to infinity, this is equal to 1. And so 2 times 1, this is equal to 2. And this value is equal to 0. Here we also use L'Hopital's rule. So this limit a goes to infinity, a squared over e to negative a. This is equal to the limit a goes to infinity 2a over e to negative a negative. And we have computed this is equal to 0. So the result is equal to 2. Now, for the case n is equal to 3, this is limit a goes to infinity, integral from 0 to a x cubed e to negative x dx. So we also use the integration by parts. So look at this definite integral. So this is integral from 0 to a x to cube negative times d negative e to negative x. This is equal to negative x cubed e to negative x from 0 to a minus integral from 0 to a negative e to negative x times 3 x squared dx. So this is equal to negative a to cube e to negative a plus 3 times root of 0 from integral from 0 to a x squared e to negative x dx. And from the case n is equal to 2, when a goes to infinity, this is goes to 2. So 3 times 2, so this is goes to 6. And here, this is also goes to 0. Here we also use L'Hopital's rule. So the result is 6. This is 3 times 2. So we can guess. So we can guess. So here we have n. If n is equal to 0, result is 1, and n is equal to 1. Result is also 1. And n is equal to 2. Result is equal to 2, and n is equal to 3. This is 6. This is 3 times 2, and this is 2 times 1. So we can guess. Just guess for general n, for n is equal to some k. K here, k is greater than 2 or greater than 1. N should the result should be k times k minus 1 times times 2 times 1. So this is equal to k factorial. For part C, we use induction to prove this result. So assume 1n is equal to k. The result is k factorial. We need to check the case n is equal to k plus 1. For this case, this is the integral, this is the limit a goes to infinity, integral from 0 to a, x to k plus 1 e to negative x dx. Here we also use integration by parts, so this is equal to the 0 to a, this definite integral, this is equal to integral from 0 to a, x to k plus 1 d negative e to negative x. This is equal to x to k plus 1's power times negative e to negative x times from 0 to a minus integral from 0 to a negative e to negative x times k plus 1 x to k's power dx. This is equal to negative x to k plus 1 e to negative x. Oh, here this is a. This is a. And plus k plus 1 times integral from 0 to a e to negative x times x to k's power dx. Since we assume 1n is equal to k, the result is k factorial. So here, when a goes to infinity, this is k factorial. And k factorial times k plus 1 is k plus 1 factorial. And the first part, this is goes to 0 when a goes to infinity. Here we can also use L'Hopital's rule to prove this is 0. So the result is k plus 1 factorial by induction. So our guess, this is true. We have proved our guess.